Hello class, hello students, welcome to the last video of matrices. In today's video we are going to see the application of inverse of a matrix, and we are using this inverse of a matrix concept to solve the simultaneous equation. Okay, we can solve the simultaneous equation by using determinant also, right? In previous chapter we had seen how to solve the simultaneous equation by using Cramer's rule. We can solve the simultaneous equation by matrix inversion method also. Okay, so how can we find the value of variable by using inverse of a matrix method or inversion method of matrix? Okay, so for that we have some mathematical concept. What is the mathematical concept? We can write the given equation in the form of Ax equal to B. Okay, where A, X and B, all of three representing the matrix. Okay, A is a matrix of coefficients of variable. Okay, so A is a matrix of coefficient, X is a matrix of variables and B is a matrix of constant. Okay, so first step is converting the equation, right? Converting the simultaneous equation, whichever equation is given, convert that equation in matrix form. Okay, write that equation in the form of Ax equal to B. Okay, so step 1 is writing the equation in matrix form. Step 1 is clear. After writing equation in matrix form, next is finding A inverse. Okay, why we need to find A inverse? We need to find this A inverse because lastly we can have X is equal to, that means matrix of variable is equal to nothing but A inverse into B. Okay, how we are getting this? We are getting this by this. Now see, as we have Ax equal to B, right? We had already written equation in this form, in matrix form. Now in both the side, okay, in both the side pre-multiply by A inverse. So A inverse into Ax is equal to A inverse into B, right? This first step, what we are doing? We are multiplying both the side by A inverse matrix. Okay, so A inverse A X equal to A inverse B. Now A inverse A is simply identity matrix, right? In inverse of a matrix we had seen this property. A inverse into A is identity matrix. So I into X is equal to A inverse into B. Okay, now I into X means simply X. So X is equal to A inverse into B matrix. Okay, so variable, to find the variable, what we have to do? We have to find A inverse and then we will multiply A inverse with B. B means matrix of constant. Okay, so first step is writing the equation in matrix form. Second step is finding A inverse, and third step is Ax is equal to A inverse into B matrix, means multiplying A inverse with B matrix. Okay, so these are the important steps of solving the simultaneous equation. See, steps are given. Step 1 is writing the equation in Ax equal to B, where A is a matrix of coefficient, X is a matrix of variables, and B is a matrix of constant. Okay, so step 1 is writing equation in matrix form. Step 2 is finding inverse of a matrix A. Okay, inverse matrix. So for finding A inverse matrix, we have to start from determinant of a matrix. So to find A inverse, first find determinant of matrix, then find adjoint of a matrix, then find A inverse. In third step, what you are going to do? In third step, A inverse. Okay, you can pre-multiply A inverse on both the side. So you will get this equation, x is equal to A inverse into B. Okay, and then we, after multiplication, we will get the variables value. Okay, so now let's see the example. Let's see one example. So here, using matrix inversion method, solve the equation. Okay, equation is 5x plus y equal to 13 and 3x plus 2y equal to 5. Okay, so only two variables are given. So let's apply the matrix inversion method in two variables. Okay, so first step is writing this equation in Ax equal to B form, where A is a matrix of coefficient. So how to write A matrix? So A is a matrix of, in first column, write the coefficients of x. Okay, in second column, write the coefficients of y. So coefficient of x, in first equation, coefficient of x is 5. In second equation, coefficient of x is 3. So 5, 3. Then coefficients of y in second column. In first equation, coefficient of y is 1. In second equation, coefficient of y is 2. So 1, 2. Okay, understood how to write a coefficient of matrix, right? Coefficient matrix, or A is a matrix of coefficient, right? So from equation, we have to see how many variables are there. So there are only two variables. So just write down above the matrix, just write down x and y, right? There are only two variables, x and y variables. Now in first equation, take the first equation and check the number with x. So with x, number is 5. So coefficient of x is 5. So write here. Okay. Now in second equation, take the second equation, number with x is 3. Right. So second coefficient is 3. Okay, clear? In first column, write the numbers of x. Okay, similarly, numbers of y, means coefficient of y. In first equation, coefficient of y is 1. In second equation, coefficient of y is 2. So A is a matrix of 5, 1, 3, 2. This one. Okay, A is a matrix of 5, 1, 3, 2. Now second, x. X is what? X is a matrix of variable. Okay, use all the capital letters. To denote matrix, we are using capital letters, and to denote the elements of a matrix, we are using small letters. So x is a matrix of, okay, here you have to write the variables. So x and y. Okay, single column, only in single column. So x is a matrix of small x, small y in single column. Okay, then third is a B. B is what? B is a matrix of constant. So matrix of constant means constant value. In first equation, constant is 13. In second equation constant is 5. So 13, 5. Okay. Like this you have to write the equation in matrix form. So A is a matrix of coefficient. Then X is a matrix of variable. Then B is a matrix of constant values. Okay. So AX equal to B. After writing this, next we have to find the A inverse, right? So start with finding determinant of A. So determinant of A, here determinant of A is 7, right? Which is not equal to 0. So determinant of A is not equal to 0. If it is not equal to 0, then only we can find A inverse, right? So since determinant of A is not equal to 0, therefore A inverse exists. Now to find A inverse, what we have to do? We have to find the adjoint of A, right? Adjoint of A. Now adjoint of A will be cofactors, right? Cross multiplication. So adjoint of A is, that is equal to, what we have to do? This is 2 by 2 matrix, right? So we have to just interchange the values of A and T. So 2 here and 5 here, right? And then B and C, what we have to do? We have to take the opposite sign of B and C. So here B is 1. So here it will be -1. Here C is 3. So here it will be -3. Right? So find the adjoint of matrix A. After finding adjoint of matrix A, next is A inverse. So for A inverse, formula is A inverse is equal to 1 upon determinant of A into adjoint of A, right? 1 upon determinant of A into adjoint of A. So determinant of A value is 7, right? Adjoint of A we had already find. Adjoint of A is 2 -1 -3 5. Okay. After finding A inverse, next is what? Next is X. So since X is equal to what? X is A inverse into B matrix, right? Where A inverse is 1 upon 7 into matrix of 2 -1 3 5 into B. B is a matrix of constant. So B is a matrix of 13 and 5. Okay. Now after writing this X, what we have to do? 1 upon 7, keep 1 upon 7 as it is, and then do the multiplication of matrices. So multiply first row with column. So 2 into 13 will be 26. -1 into 5 will be -5. So 26 minus 5 will be 21. Then second row with column. So second row -3 into 13, that will be -39. Then 5 into 5 will be +25. So -39 plus 25, that will be -14. Okay. So 1 upon 7 into matrix of 21 minus 14. So now what next? We have to, if possible, then only we have to divide this elements of matrix by 7. Since 21 and 14 both are multiple of 7. So we will divide this elements by 7. So we get 7 3s are 21. So 3, then 7 2s are 14. So -2. Right? Now by equality of matrices, here it is matrix X Y is equal to matrix 3 minus 2, right? So by equality of matrices, we can say that x equal to 3 and y equal to minus 2. Okay. So concept clear, how to find the, or how can we solve the simultaneous equation by matrix method? So to solve the equation by matrix method, just go step by step. Step 1 is first write the equation in matrix form. That means write equation in Ax equal to B. Capital letters, all are capital letters, where A is a matrix of coefficient, X is a matrix of variable, and B is a matrix, this is B, B is a matrix of constant. Okay. Then after writing equation in matrix form, next we have to find the A inverse. So to find A inverse, first we have to find the determinant of A, then adjoint of A, then A inverse will be 1 upon determinant of A into adjoint of A. Okay. Then next is A inverse, X. Next step is X. X will be A inverse into B matrix. Okay. So write, since X is A inverse into B matrix, so write A inverse into B. Then do the multiplication of matrices, right? Then if possible, then divide by the number or multiply by the number. So after doing all this calculation, by equality of matrices, we will get x equal to 3 and y equal to minus 2. Okay. So class, this is the method of solving simultaneous equation by matrix inversion method. Okay. So with this, I am stopping this video. In next video, we can see the more example of solving simultaneous equation by matrix inversion method. So thank you class.